Hello students, this is Mrs. Gregorio again, and today we are covering Chapter 1, Lesson 7 on constant rate of change. Take out your books and follow along on page 65. To begin, I'd like to introduce some vocabulary words to you for this chapter. The first one is rate of change, and this phrase, rate of change, refers to the rate that describes how one quantity changes in relation to another quantity. So we are going to be comparing two different items. Sometimes it will be distance over time. Sometimes it will be in price per hours. Those are some examples of different quantities that we'll be comparing. Now, a constant rate of change is in a linear relationship. The rate of change between any two quantities is the same. So if the rates are changing by the same amount, we have a constant rate of change. This is similar to the constant that we were referring to in proportional relationships. Today we're going to take that knowledge that we've had and apply it to our graphs. So to start, I would like you to complete the real-world link on page 65 in your books. Be prepared to discuss your thinking in class tomorrow and show your work. Pause the video now and work on the real-world connection. On page 66, we're going to start example 1. And we're going to practice by using a table. You can use a table to find the constant rate of change. Number 1 says, the table shows the amount of money a booster club makes washing cars for fundraisers. Use the information to find the constant rate of change in dollars per car. So here is our table for cars washed. The number of cars is listed below, and the money that it cost, or money that they earn, is shown to the right. So for washing 5 cars, they make $40. 10 cars, they earn $80, and so on. Now, in order to find the constant rate of change in dollars per car, we have a hint here, and our hint is to find the unit rate to determine the constant rate of change. So we need to look at first the change in money compared to the change in cars. How much does it cost per car? So I'm going to write this out. Change in money. Oops. My smartboard's not very aligned. I apologize. Change in money divided by the change in cars. So I'm going to color code this. I'd like you to write this down in your notes, please. The change in money, if we look on the right-hand side of the graph, from 40 to 80, you can see that it increases by 40. From 80 to 120, it increases by 40. From 120 to 160, you can see that it increases by 40. So the change in money is constantly changing $40 each time. Now we're going to compare this by the change in cars. 5 goes to 10 by increasing by 5. 10 increases by 5 to go to 15. And 15 increases by 5 to come to 20. So the constant change in cars is changing by 5. So here we have a fraction 40 over 5. That is our rate of change. Now we can take that rate of change and simplify it into the unit rate. So $40 for every 5 cars is the constant rate of change. This can be reduced. Divide the top and bottom by 5 and you get $8 for 1 car. Now since every car costs the same amount, you can state that it is a constant rate of change. So we've showed the amount of dollars per car. Now this is very similar to unit rate. Okay. Go ahead and finish taking your notes. If you have any questions about this, write them down now. If you are ready, I would like you to try A and B on the bottom of page 66. Go ahead and pause the video to continue those problems now. For example 2, we can use a graph. So instead of using a table, or in addition to a table, we can also evaluate the constant rate of change by analyzing a graph like the one you see here. The graph represents the distance traveled while driving on a highway. Find the constant rate of change. Okay, so to understand what this graph is representing, first I would just like to highlight a couple key points on your graph. The time is on the x-axis, and you can see that the time is increasing by increments of 0.5 or half an hour. On the y-axis, you have the distance, which is being measured in miles, and the miles are increasing by 20 miles for every interval. Now, to find the constant rate of change, we want to look at the change in miles, which is on the y-axis. So I'm going to write that down. We have the change in miles. Please be taking these notes as I write them down. And we're going to divide the change in miles by the change in time. And the reason why we're comparing this is because this is going to help us understand the graph a little bit better. Miles is the y-axis, and time is on the x-axis, and that will become important in the next few chapters coming up. So for the change in miles, you can see I already have it highlighted in blue. Now on the y-axis, the blue dots go up by 60 every single time we go to the point. So it goes up 60 and then over some. Up 60 and then over. Up 60 and then over. So the change in miles every time is 60. Now the change in time, we're going to be looking on the y-axis now. And here you can see that it is changing. Let me move that line up just a little bit. Oops. It's not quite lined up. Let me fix that. I'm sorry, my smartboard is not cooperating at the moment. So on the dotted red line, you can see that the time is increasing by 1 whole hour to the right. That's better. There we go. So every time we move the point, it goes up 1 hour. Here, it's changing by 1 hour. Here, it's changing by 1 hour. So every time we add an hour, the graph is changing 60 miles. So we have 60 miles per 1 hour. So I'm going to write this down. Okay, 1 hour. Now, since we have 60 miles per hour, there's another way you can look at this, and this is to identify the ordered pairs. The points in the ordered pairs, first of all, it starts at 0, 0, the origin. So I'm going to label my graph with the points 0, 0. The next point is 1 for the x, 60. The next point is 2, 120. And this third point up here is 3, 180. You can pick any of those 2 points and just subtract the difference. Let's say we wanted to choose 60 and 1, or 60 miles in 1 hour here. And let's compare that to the points 0, 0, the origin. If we look at the change in miles, we can take 60 minus where it started, which is 0. And then if we wanted to compare that to the change in time, we would take the 1 hour for the x point minus 0. So 60 take away 0 is still 60. 1 take away 0 is still 1. That's another option of how to check your change in miles per hour. You can look at the graph or you can look at the coordinate pairs. It's up to you. For example 3, I would like you to explain what the points 0, 0, and 160 represent. I mentioned that earlier in this video, so if you were listening carefully, you will already know the answer. If you need to replay example 2 for your hint, please do so now. Please write your answer in the work zone for number 3 to get credit for this assignment. When you are done, continue on with C and D on page 67. Please pause the video now to work on those 2 examples. Okay, moving along to example 4. It says the table and graph below show the hourly charge to rent a bicycle at 2 different stores. Which store charges more per bicycle? Explain. So looking at the table, the first store I see is called Pedals Rentals. Here we have the time in hours, and here we have the cost in dollars. 2 hours cost $24. 3 hours is $36, and 4 hours is $48. So I just want to take a moment and analyze this table. Let's look at the change in cost first. Now, the cost increases each time. From 24 to 36, it's an increase of 12. From 36 to 48, it's another increase of 12. Now, looking at the change in time, from 2 to 3, that's increasing by 1. And from 3 to 4, it is increasing by 1 as well. So if we wanted to compare the change in dollars over the change in hours, we can find that the constant rate of change is $12 for every 1 hour. So that means every hour of the rental for the bicycle will cost $12. It is changing at the same rate, so it is a constant rate of $12 per hour. Now let's analyze the graph. This graph represents a store called Super Cycles. And Super Cycles has an x-axis, and it is not labeled on mine, so I'm going to label it now. Your book is already labeled. The x-axis is your number of hours. Your y-axis represents the cost in dollars. So I'm labeling this now. You will notice that the hours increase by 0.5 every single time, and the cost in dollars is increasing by intervals of 2. Now, looking at the first point, it does pass through the origin at 0, 0. So I'm going to label this point 0, 0. The second point here on the graph is over 1 up 8. So 1 hour costs $8. At the second point, we have over 2, and it intersects at 0.16. So 2, 16 is our second point. And you even have a third point. Mine is cut off a little bit. At 0.3, it would be way up here. 3 hours, it would cost $24. So once you have labeled those points, you can look at the change in dollars compared to the change in time. So I'm going to pick just the first 2 points. I'm going to pick 1, 8 and 0, 0. I choose the origin because it is the easiest number to work with. The change in cost is 8 minus 0. I'm using the 8 in the y-axis, or the y-coordinate point, and the 0 of the y-coordinate point. So $8 take away $0. This is my vertical change. Now, for my horizontal change, I have 1 for my x-coordinate and 0 for my other x-coordinate. This is your horizontal change. So every time the graph has a vertical change, it goes up 8. And every time it has a horizontal change, it's going over 1 hour. So it's a constant rate of change of up 8 and over 1. 8 take away 0 is 8. 1 take away 0 is 1. So that means that super cycles charge $8 per hour. So the question is asking which store charges more per bicycle? Well, the answer would be Pedals Rentals charges more. Pedals charges $12 per hour. Okay. Please write out that sentence in your workspace to the left and be able to explain your thinking to a partner tomorrow. Okay, for tomorrow, please be prepared to work on the guided practice and independent practice in class tomorrow, and we will go over any questions you have. At this time, we are done with the video. If you have any questions, write them down and be prepared for the next lesson. I hope you have a great evening, and I'll see you then. Bye-bye.